Great. So today we're going to talk about visualizations. Um, and this will be one out of two lectures. While making this lecture, I realized that visualizations are actually way more complicated than I remember. So I've decided to split into two lectures. Today we're going to be talking about mainly distributions and like types of variables that you can plot. Right. Oh, okay. So first of all, a quick review from last week where we talked about group by was something the most important thing that we talked about, right? So this was like the famous picture I told you guys to like absorb, where what the group by is doing is that it's grouping all of these. If you group by this column, it's putting together all these ones in the same value in that column, right? It's grouping them together. And then you're collecting these values in some way, right? So in this case, I've grouped by this ABC column, right? And I collect it by the minimum, right? So these three values, what's the min of these three values? It is 1. So that's why 1 gets outputted here, right? The min of these three values is 2, which is why 2 gets outputted here. And you can test for any of these other like boxes or like mini data frames, right? Where like, for example, this one, the min of these three right here is 4, which is why the output is 4, right? The formal definition, right? It splits the data frame into categories, applying a function on those categories combines the results back into a data frame, right? So calling group by itself generates these group by objects, which are useless until you aggregate them somehow, right? So these are like the mini sub data frames, right? And yeah, finally, we talked about the aggregate function, which this is like aggregate just means pretty much joining all together and smushing it into one value, right? So this can include like sum, max, min, first are like definitely like the most common ones. It's like the mean, right? So in this case, in this baby names case that we looked at last time, right? We have a table of baby names. We group by the year. So all the rows of the same year we put into their own stub data frame. And then what's going to be output is how you aggregate in this case, the numerical column, because these other string columns were omitted when I made this visualization. And yeah, I gave you guys a little sneak peek of like plotting. This was like the number of birds in California, right? And the x-axis was like the year, and you can see like the steady increase and then the decrease. Yeah, so this was all last week. If you're sort of like still unfamiliar, it's okay. You guys can go back to the last week's lecture. This week we're going to talk about sort of a completely new chapter, new idea, which are visualizations, right? So like this plot I made here, how do I make this plot that you guys see here, right? So visualizations. Oh yeah, a quick warning before we begin. When I talk about like a plot or a graph, there are like hundreds of ways to make a graph, right? So you can change the color, the opacity, you can change the label font, you can create a hue. If you want a dotted line, you can do that. You can plot multiple lines. You can have side-by-side plots, right? Etc. There's like millions of things you can do. I will not teach you how to do all these like custom things. If you want to know how to do the custom things, I recommend you either read the documentation, Google it maybe. I probably don't know all these customizations at all, but if you want to become proficient and you have like a unique style that you're looking for example, I recommend you look at the documentation. So first of all, I think this. Did I skip a slide?
I feel like you guys should go first.
Oh, I did skip a slide. Okay. Yeah, I don't know where this went. Okay. Yeah, so first of all, what are we doing? Right? So the goal is to represent the data in an interpretable plot, right? So what I mean by that is you can visually see like an idea of the plot, right? And in other words, like the more technical terms, we're trying to plot a distribution, Now, this includes a set of values of the variable, right? Or the frequency of which the variable occurs, right? So what this inherently means is that the sum of the percentages, if you're using proportions, should add to 100%, right? Because then it wouldn't make any sense. Or the counts should sum up to the total number of data points, if that's what you choose to use, right? And I briefly mentioned this before, but when visualizing, the type of variable we're visualizing really matters, right? So, and there are four main types of variables. You split off these two categories. One is quantitative, one is qualitative. And the quantitative has two types of quantitative variables, or continuous and discrete, which I'll talk about both of them. And the qualitative data has ordinal and nominal. Qualitative, you can think of like quality. Okay, not really, but like, okay, I guess quantitative, you can think of like quantity, right? It's like numbers, numerical data. Qualitative is are more like strings, right? And I'll give you like more examples of these. So first of all, I'll talk about visualizing qualitative data because it's actually significantly not easier, but like more certain in like what to do, I guess. So first of all, what is a qualitative data variable? Right. So a qualitative variable is a variable that is not numerical. And that is literally like the best definition I can give you. And there are two types of qualitative variables. Right. So one is called ordinal, which, as like the name kind of sort of suggests, there's an order to the variables. Right. So this can be like low, medium, or high. This could be or like first, second, third, right? So like these are like there's clear distinctions of levels of like this is less than the other, right? But notice that these are not numbers; these are like strings, basically. The other one is nominal, and this is actually, I guess, far more common, where there are no orders to the variables, right? So, for example, like eye color, or college major, or like which city you live in, right? For example, right? So this is like the I guess the holy graph everybody looks at when they look at variable. And right now we're looking at this like left half, like this qualitative, nominal, ordinal section. So visualizing, right? So how do we visualize it? The most common way to visualize qualitative variables is with a bar plot. And it's actually kind of like the only way. There's like this is like the by far the most common. I really haven't seen anybody use anything else that often. Um, there's a pie chart which exists as well, but that is like heavily looked down upon in the data science community because it's like very unclear. So I assume you guys are familiar with bar plots, right? It's I'm hoping you guys learned it in like middle school or something. Where the x-axis is just your categories. Well, you can make it like a vertical one if you want, or sorry, horizontal one if you want, right? But and you have like a count or like a proportion that I mentioned before. This is our baby names data set last time. Uh, the you can see like the amount of males born in California is like a little more than the amount of females. I don't know why it's not 50-50, but like this is how the data was recorded. So this is like a standard bar plot, right? So how do we actually plot in pandas? Um, the two main ways are there's two libraries that we use. It's called matplotlib or Seaborn. I personally prefer Seaborn because it's like newer and like the functions are easier to use. Uh, but I guess matplotlib is like very you can think of it comparing it to like C and Python, I guess. It's just like kind of your personal preference. Um, yeah, so like first of all, like brief introduction to matplotlib, right? So all of these, I should probably mention this now. All of these functions, these plotting functions, they have like the same structure, right? Which is like luckily, I guess, right? So in the matplotlib plotting structure, we pass in a sequence. So this can be like a list, array, and more often than not, a series, right? A column in a data frame, a values to be plotted on the x-axis, and then a second sequence of values on the y-axis. And that's just how you like shoot out your plot, right? So like in our baby names example, that's this plt.bar, which is this bar plot. And you have your column, you have your second column, and then you output this, right? Very easily. You just run this in the notebook and I'll output. Seaborn, my preference, like I mentioned, is slightly different in structure, but there's like really no difference, like key difference between Matplotlib and Seaborn, I guess. It's just, like I said, completely your choice. In Seaborn, you pass the entire data frame, and then you specify like which columns you want to plot, right? So it'd be SNS, which is like the shorthand for Seaborn. To use Seaborn, oh shoot, I should probably write this in the slides. Import Seaborn as SNS. SNS is just like the most common shorthand we use. Matplotlib, we use PLT. Oh shoot, we might. I just realized you need. Okay, this might be wrong. I think it's actually. Sorry, I was like made these slides like really quickly. Matplotlib.py plot. I think it's this. Uh, yeah, I'll let you know if this is wrong later. But like I guess try it out. If an errors, then search it up. Yeah, but Seaborn, like some reference, you press in data frame and you put in X and you press your Y and it just plots. Right. So like everything works as intended, I guess. Yeah, oh yeah, quick notes. Right. So to add labels, you just do plt.x label and then your x-axis label, plt.y label, your y-axis label, and plt.title, which is and then the title of your plot, right? So these are very important because it's very important for the person looking at your plot to understand what the plot actually is about, right? So I guess in this, if I like manually change this, this is like what it will look like, right? Like so, this is very, very important, right? There's also like a plt.legend, which you can like if your graph requires it, you can like create a legend right here. But that'd be like more relevant when you like queuing stuff or like plotting multiple things on one graph. Um, and this is like a little bit about what I mentioned before. Um, every single graphing function has an insane amount of details and options that you can do to like customize the plot, right? So for example, seaborn.barplot, which is literally the function we just used to plot this graph, right? You see data none, your x equals none, y equals none, and that's all we used, right? But if you notice, there's like millions of like things you can do, right? So like you can have hue, right? You can order the hue, you can have estimator, right? And native scale, you can have a log scale, with yada yada, right? And this is what I meant by like it's very. I'm not going to teach you the specifics, right? So you're gonna have to learn specific. I'm just going to teach you like the high level how you plot the bar plot and when you use a bar plot, right? And I guess the golden rule is if you're plotting strings or like non-numerical data, you should just pretty much always use a bar plot. Um, I guess a line plot sometimes, but I'll talk about that like completely later. So I guess how to plot quantitative variables, right? So if we look at this x-axis, this is the gross national income per capita. This is just some graph I borrowed from uh, my school, actually, my school's data set, one of my school's data set, right? So if you look at this x-axis, okay, so this is a bar plot of all possible numbers of like income, I guess, right? And this is like completely unintelligible, right? Because you have so many numbers. They're not grouped very well because they're like exact numbers, right? And this is like there's like way too many things. It's just a very ugly graph, and you don't actually see anything in this distribution at all, right? Um, so the bar plot cannot work in this scenario. So did I skip it? Oh, I guess I didn't. Um, so so this is what I mentioned before. One of the quantitative variable, right? So I guess I should assign what a quantitative variable is, right? So this is anything numerical, but with a common scale, Now this point is actually very important, right? So a few examples of quantitative variables are GPA or income, right? Where your GPA is like 3.7, like 3.8, right? And 3.8 is obviously greater than 3.7. Um, non-examples are things like Yelp ratings. This is a very, I guess, debatable and like very, what is it, common misconception that this is, even though Yelp ratings are like 2.5 out of 5 stars, right? Like 4 out of 5 stars. And you might think that like 4 is greater than like 2.5 stars, for example. However, there's no common scale, which makes this like not a quantitative variable. There's like this was like actually like a whole debate at my university. And yeah, many of these are like very debatable, but you just like plot whatever you want, I guess. But the reason why Yelp ratings are not classified as quantitative is because different people are grading on different scales, right? So like the value of a 5 sort of doesn't mean much. As in like, so if like I rate it and Michael rates it, right? My dad rates it. My dad is like very generous or something. He rates like everything 5 out of 5, like 4.5 out of 5. But I'm like, okay, 3's average, right? So I just roll like everything like 2 or like 3, right? It's like Yelp ratings only matter when it's rated by me, right? And those restaurants, right? Otherwise, it's like very controversial and sort of meaningless to compare like my ratings with Michael's ratings, right? Continuous, which is what I'll be talking about how to plot first, just means within the real numbers. So if you like look back into your like middle school math class, the real numbers are just basically numbers that can be anything that are not complex, right? So like pi, like irrational numbers, right? Are part of the real numbers. That's like the key distinction, right? Integers are part of the real numbers, rational numbers are part of it. If you forgot, rational numbers are just numbers you can represent as fractions. Irrational are just ones that you cannot represent as fractions, right? And real are just encompasses all of them. So income would be an example, right? Or distance would be an example, right? So it's like where the value this would make sense, right? And discrete is a little different, which is like right here. Discrete is a little different. Discrete refers to like numbers with like gaps in them, right? So like count is like the most common discrete variable because it doesn't really make sense to have like 3.75 count of something, right? Because like what does 0.75 mean, right? It doesn't really mean anything. So that would be like a discrete variable, right? But continuous variables are this value would make sense. I guess is the key point.
Yeah.
So there's 3 main ways to the slides. I don't know why this guy did that. Okay, there's 3 main ways to plot continuous quantitative variables, right? So there's the box plot, the violin plot, and the histogram. There's also the KDE plot, but I've like not sort of omitted that because that might be like too advanced. But I'll get like a temperature check maybe if I want to go over it next week. But the box plot and the violin plot, oh, I'm hoping at least the box plot you've heard of before in your math class. But the violin plot is like basically almost the same thing. And I would note that the histogram is definitely by far the most used one, right? So if you look at all 3 of these graphs, which one is like the most obvious, I guess, in the trend, right? And it's in my opinion, it's definitely the histogram. And in many other people's opinion, it's actually definitely the histogram. And that's why like the histogram is used so much. So I'll talk about like the subpar graphs, I guess. Right. So those are the box plots and the violin plots. So like I said, I hope you've heard of the box plot before. Where it plots the minimum, right? The maximum, or sorry, the minimum, the maximum, and then the quartiles, right? I'll explain what the quartiles are in the next range, on the next slide, where this is like the 50 percentile, which is the median. This is the 25 percentile, and this is 75 percentile, and it creates this box. And it's important to know that the width of this box means nothing, right? It's like if I made this box like a little longer here, it would not change the information on the plot at all. So how you plot this is very, like I said, it's always very convenient, right? So like seaborn.boxplot, data equals df, and then just the y variable, right here as a column in your data frame. Matplotlib, I guarantee is going to be like very similar to this. It's like little variation between the two. Yeah, but note like the very nice and compact notation to like make this plot, I guess, right? The next, which maybe you've not heard of before, is the violin plot. This is literally just a box plot, except the width now matters. Right? So the width now indicates the density of the data points. So in this case, this like wider region. Also, like there's no difference between the left half and the right half. It's like you can think of it as like mirrored on top of each other. There's no difference. So this like width right here is like how many points are in that plot, or like at that point. Not at that point, but like around that point, I guess. Also, I forgot to mention these little dots are just outliers. And if you look at like gross national income, I guess there's a lot of outliers, a lot of people who make a lot of money, right? So this is probably like, I don't know, Elon Musk or something, which is, all right. Oh, if we look at like the histogram before of the distributions, it becomes like very obvious that these outliers exist, right? So this is what I meant by like the histogram is like a lot more apparent in my opinion. Yeah, so quartiles, I'll briefly mention this. This is just what's plotted here. So this is the 75 percentile. The box plot, I know the dot is the median. I think I forgot where the 25 percentile and the 40. I forgot. I think it's right here. I think this is 75%. I think this is 25%. I mean, this just goes to show how, I guess, non-commonly used these guys are. But I think you guys are like use this in your math class all the time in middle school for some reason. So this is like the 75 percentile, 50 percentile, like I said, 25 percentile. That's just like if you cut it in half, that's the 50 percentile. You cut the left half in half, that's 25 percentile. The right half, 75 percentile. And then the IQR, which I'm hoping you guys have learned about as well. It's just the third quartile minus the first quartile, this is like the middle of the data, the middle 50%. It's just like a statistic some people use sometimes. It skipped again, didn't it? Okay, yeah. So the next, in my opinion, the most useful one is the histogram. Like I said, this is by far the most used, right? And you can think of it as like a bar plot, but for continuous variables. Right, so you have this very nice looking histogram where this is like histogram of weights. I actually don't even know what that means. Or I guess like weight of people, maybe. And it's like, okay, yeah, frequency. So histograms, like I guess, formal definition is it collects data points with similar values into a shared bin, and then it scales the bins such that the area of each bin is equal to the percentage of the data point it contains, right? So in this case, the size of this bin times this height, which is value here, would be like the percentage of the bin, or like percentage of data points in that bin, right? You see, this is like 1 to the e-5, right? So don't be like fooled by the 7 right here. Yeah. So how you plot them, which is I guess why we're here today, right? Is in matplotlib. It's the pattern is like always the same. So plt.histogram, your x values, and then what metric you want to plot, right? So density, just you can think of it as proportion, basically, is what you're plotting, right? It's like percentage of the data is in that bin, or like the count and then scaled down, I guess, right? So in Seaborn, again, very similar. As soon as that his plot, data equals df, x in your x column that you're plotting, and then your stat equals density. So if we look here, this is like the matplotlib plot. This is the Seaborn plot. I'm actually not exactly sure why they're different because normally they're the same. If you looked at the bar plots and like the violin plots are like basically the same, but like these have like visual differences, I guess. A small note that's like maybe a little, I guess, kind of important. So maybe I should have mentioned a bit more in the slides is that you can have like parameters in here. And one of the important ones are like you can specify the bins that you want exactly. Right. So I'd like list the bins right here. It's like I'm like 0 to 20, or like 20 to 40, for example. Right. I can specify like the opacity, which this is like relevant when you have two histograms on top of each other. You like want to see each other, right? I think I have an example later in the slides of this. And how you specify the opacity is with the alpha parameter. You know, border colors, right? So in this example, like the border colors are white. There's like there's so many customizations that you can do, and if you want to like dive into it, then by all means, right? Just know I will not be teaching you how to do that. In this at least in this slideshow. Okay, yeah, I actually do have an example of overlaid histograms. So I will specifically mention what's called the hue parameter, um, which I guess it's kind of not easy to explain what that means, but I guess like an example is a lot better. So overlaid histogram, as you can probably guess, is just two histograms on top of each other, right? So you can like compare their results, right? And what this hue means is that I have like an A color and a B color, or like two categories, two categorical variables, and I want to like split the histogram by those two category variables so I can compare those two, right? So in this case, the hue is hemisphere, right? When it comes to national income per capita, so in the southern hemisphere, uh, you can see that in this case, like the income is significantly lower than the northern hemisphere, right? And intuitively, um, I guess that makes sense because I guess all the world powers, all like the historically powerful countries are in the northern hemisphere, right? Oh, actually, that's not true. But like,
200%.
I guess like GDP wise, like all of them are in the northern hemisphere, right? Um, Actually, that might not be true either. Okay, anyway, whatever. Um, yeah, so like this is like a overlay histogram, right? And you literally just have to add this little keyword right here, hue equals column name. You get this like very fancy, nice plot, right? You can compare two strings at once. Um, yeah, so again, like I said, the structure is always very similar. So there's like kind of no point in reiterating this over and over again, right? It's plotting is very easy, right? Right. So SNS.hips plot, theta equals df, x equals this, stat equals this, you're done, right? It's setting up the data that's like sort of the hard part, which is like why the group I exists, right? Um, also, I assume you guys know what like skew means and what modes are. But I can like, in case you like forgot from, I guess, middle school, I think it's like you guys learn this stuff. Um, like skew is like, you can think of it as like the tail, or like this is called like right skewed, right? Because like the tail is on the right, which means like most of the data is on the left. That's what like right skewed means. And then that skews off to the opposite. And then modes are, it means like how many peaks are there, right? So this is like unimodal, right? Because there's only like one peak. But if you have like two peaks, right? So like it looks like a bridge, maybe. Like I don't know if you know what I'm talking about, but like an M, maybe. That would be like bimodal. And then there's like I forgot what the third one was for like the multiple peaks. But yeah, just note that that exists and that's like a term. Um, and of course, the skewness matters like quite a lot. Um, and I can go into more detail if you guys like would like me to, but I sort of assume you already know like what the importance of it is. Oh yeah, and finally, I'm actually like going through the slideshow way faster than I anticipated, so I guess we're gonna end a little early today. I guess visualization is just that simple. Um, but finally we have the quantitative discrete variables, right? So like right here in this graph. I mentioned this before, but I'll reiterate. So quantitative discrete variables are just numerical value variables with gaps in between them. By gaps, I mean by like for example the integers, right? Like the big Z, right? So that'd be like 1, 2, 3, 4, -1, 2, right? But like -2, and like it's like 1.5 is not in the integers, right? Because that's not an integer, so it wouldn't be in there, right? So that's why it's called like a discrete variable. As mentioned before, the most common example is count, right? So if I'm like counting humans, and like previously in the plot I made where my y-axis was the count of people born in California, right? 34.67 humans doesn't make any sense, right? Because like, well, what does 6, 7 humans mean? Sorry. Um, Most of the time, this is also very important. Dates slash time fall into this category um, of discrete variables. I know like time wise, you could like get it down to the nanosecond or like picosecond or whatever and get like this very exact numbers. But at the end of the day, most of the time you're working in seconds, you're working in minutes, or working years even, right? So that's why it's most of the time it's discrete, where you don't have like a you're like 2004.5, for example. That's like not a thing, right? Um, yeah, so because there's like only like a limited amount of time, you actually use bar charts quite a lot to visualize this. Um, and you sort of like omit the x-axis like quite a bit, so you don't have like that really cluttered thing. Um, yeah, but we've already talked about bar plots. So the other way are line plots, and line plots. Uh, there's like two. I guess I mean bar plots are kind of like this as well. So it's like technically not a distribution, as it's like it's not like a singular variable, but it could be. Um, and I'll talk about this like a lot more in depth in the second lecture. Yeah, but like line plots are like sort of the other option and sort of the original graph I showed you guys. So yeah, but here, so notice like my x-axis are years, right? Notice I don't have like a 1960.5, right? As I mentioned before, I only have like 2000, it goes 2001, then goes 2002, right? So that's what I mean by like discrete. There's there's like holes in between. And it's very important that the intervals are like the same interval, I guess. Um, and again, the how you plot it in code is always the same, right? It's like there's no difference. They don't make it confusing for you, right? So like you call seaborn SNS.line plot, so your data, so your x-axis, so your y-axis, and then you're just done. Right. So how I made that plot last time was that I had my group by table, and I simply just put the year and put the count. Right. A small tip is that if you want to plot like 7 lines on this plot, so like a very common example is like you want trends for every day of the week. You want to see if it like the trends differ on Monday, Tuesday, Wednesday, etc. Right? You can run a for loop and just plot, like run this SNS dot line plot over and over again in that for loop, and you just plot all those lines, changing your x value slash y value when you plot. Or sorry, not the x, changing your data when you plot, right? So you like filter your data whenever you plot the new for loop, right? In the for loop, so you get like 7 lines. Um, and like I mentioned, this is like worth mentioning because it's so common, and especially when you're in your guys' cases where you're going to be plotting like air pollution, or like water pollution or something, right? And like the date like really matters. right? So this is become like very important, where a very common x-axis is what is called the date time object, right? So like normally dates are given to you as strings, and the problem with that is that you'll have this like really cluttered like, x-axis, right? And if you like dates are missing, for example, um, it won't show in the plot, right? Because those are strings. The thing that's plotting the distribution has no idea what the values means. They just plot them next to each other, right? So if I have like 1960 and then I have like a gap 20-year data, right? It'll just plot 1960 and like 1980 right next to each other. And that's obviously not what we want, right? So instead, since it's so often used, it's called the datetime object. This is actually not unique to not pandas. This is like a Python data object, right? And this is you can just think of it as like another data type in Python, right? So like an int or like a string. You can use the date time, and this just has like a lot of convenient features, right? So you can call like they have like a lot of features. There's like you can just call date time or time to get the time, right? Time delta, which means like the difference in time from some other time. You can date time a month and just like immediately extract the month out of the date. Um, Pandas also has like a to date time function, and which input is like a string with date format, um, or yeah, like this can take in a series, which is like why it's so important. So you like put in like a generic regular expression format, which I don't think I want to tell you guys about regular expressions, but I like there's an example back here. But like you just like very minimally need to know. It's like for example, like this 5/20/24, like May slash I meant oops, okay. I meant for these to say the same date. Uh May 20th, right? So these are like two different ways to represent the exact same date, right? So if you're that's like very confusing to I guess the computer. So which is why like this date time exists, right? And you like if you're given a date in this format, you have to convert it into a date time, right? If you're given it instead of you're given a date into this format, you have to convert it manually into this, right? Uh, yeah. So like I said, dates come in a variety of forms. So dot date time can take in many parameters to accommodate specific date times, right? There's sparse-limited list, and if you click here, you can open the documentation to like see like what could possibly be it, right? A very common structure. This is like a very common like time, I guess, type you see is it's like 2018-10/26, and then like the time like this. Um, so like how I would convert this string into a date time is you pass in this format keyword, right? And you put this like %y, which specifies the year. Then you have the dash, which is right here. Then you see the 10 in this dash. Then you see this 26, right? And then hours, minutes, seconds. And then F, I don't know what this is actually. I think this is milliseconds or something, or floating point or something. But it's like not important. But like notice like the colons here, these are like literal colons, right? Because that's like this is like sort of the pattern it's trying to extract out of here. It's basically what's going on. Um, oh, okay, this is actually the end. Yeah, so I guess I'll be ending a little early today. Um, but next week we'll be plotting a relationship between multiple variables instead of just like one distribution, right? And I'll also talk about transformations. Um, this might be less relevant, but I think it's still very important to at least briefly mention. Um, we'll talk about like the fancy plots as well. So like, okay, scatter plot is of course like the most important ones, and I'm sure you guys have like used this quite a bit or like very familiar with it. There's something called the hex plot. This is what you guys see here. It's a very visually cool. Um, Sadly, visually coolness is like not that important when it comes to data science. Oh, I guess it's like sort of important, but I barely use people see people use hex plots before. There's like contour plots, which what how do I explain contour plots? Um, it's like like a plot of like mountains, right? It's like 3D. Um, like in like a hiking trail, something is like a 3D sort of like image, right? If you like squash it down, right, and like the thicker regions, like the ones where like there's more stuff squashed down on it, will be like darker, or like yeah. So like I guess like a color. Okay, whatever. I'll just explain it next week. There's joint plots, which is like for example this thing, which is like three plots on one, which is like a very cool visualization, right? Um, it's just like for compactness. If you want to plot like I guess this is a KDE plot, um, right? And then like your data points and scatter plot. So it's like heat maps. Um, I'm not sure if I want to talk about KDE plots. I might get some insight from the instructors if about KDE plots, but these are like kernel density estimates, which are very important, no doubt, but it's like very complicated to like sort of understand, and maybe 3D graphs. And these it might be like too advanced to plot. This like it's like sort of very hard to plot. It's not like a one line of code like what you guys learned today. You can just like plug in one value and you're just done. All right. And then next week I'll also, if I have time, I'll talk about is what makes a good plot. There's like many issues a plot can run into that you as a data scientist has to solve, right? So like for example, overplotting is like one of the most greatest things that can happen in scatter plots where you have like too many data points so you can't tell what's going on. There's another thing with bar plots where I forget what the exact words are called, but it's called like bobbling the x-axis or something where uh it's sort of like you can't tell that like this has like the same value as the other because like they're like different heights if you have like a stack plot. Um there's also uh oh yeah, there's like there's a the importance of the y-axis is another thing where like a lot of news companies will they'll just cut the y-axis in like half so like the difference looks a lot bigger than it actually is. Um yeah, so I'll talk about like all those things as well. I guess this week that's all for today. Oh yeah, there's like a little extra snippet. Um the pandas also has a plot function. Which if you're lazy might be more convenient for you, right? Where you just like specify the type of plot you want. So instead of doing like SNS dot hist plot or like SNS dot box plot or something, you can just do like you can just use this generic plot and just like put kind equals hist, right? I will know this is I normally use this when I want to create subplots because it's like very convenient, as you guys can see here. Um, also, well, I know there's yeah. So there's like something called stacked in here. Um, okay, whatever. I'll find it later. But it's like this is actually the only way I know how to make a stacked bar plot. A stacked bar plot is just like multiple continuous variables on like the same bar plot. I guess we have a little bit of time, right? Okay, yeah. See, I've searched it before. Stacked bar plot. That's like this. That's a stacked bar plot. Um, yeah. So that's actually it for today. Um, have a nice spring break. Because I mean, if you guys have it, yours might have been like 2 weeks ago, actually. And that's it for